Okay, fractionation unit. Fractionation unit is a unit that is like few distillation columns that are connected in series. Okay, we have 3-4 distillation columns that are connected in series to each other. Okay, and in general, like this kind of unique fractionation unit that we have them even also in the refineries, is to separate different molecules based on their boiling point. Light molecules, light products like gases, they have lower boiling points. Heavier molecules, bigger molecules, they have higher boiling point, or higher molecular weight and higher boiling point. So we use distillation column to separate molecules that they have different boiling point or different molecular weight. So we can apply this process both in crude oil processing or in general hydrocarbon mixtures like in natural gas processing. So each of these, the output of each of these units, it becomes the feed of another unit. So I'm going to talk a little bit in more details about them in the next slide. So this slide is mainly kind of introduction slide. So it is the most important process in general in LNG plant because its operation really affects the next one, because you see it's the unit that has a lot of outputs. One here, another one here, another one here, another one here. So it has since there are several outputs, and all these outputs are going to another unit. So any change in the process will change any subsequent units. Okay, so operation of this unit is very crucial because it's connected to many other units. Okay, fractionation unit, we also call it distillation unit or distillation tower, that we just use distillation towers to separate different fractionates, like different molecules based on their boiling point. So it's very important unit because we do a lot of separation. We separate molecules that they can be used for sale, or they can be used to convert it to some other products, or they are the feed of another unit, especially in the case of LNG process. The process, the separation, is based on difference in the boiling point or molecular weight, and it has mainly these 4 units: De-ethanizer, De-propanizer, De-butanizer, De-isopentanizer. Okay, so we show this equipment in the next slide, but the good thing is that all these units, all these equipments, they are totally similar to each other. Okay, they are the same distillation column. The only thing that will change is the operating condition. Let's say this unit, the distillation column in the De-ethanizer distillation column, works in, let's say, a certain pressure. The other one has different pressure. The temperature, and also the number of trays in different units might be different, because this tray distillation column that has several trays. So the only thing that will change is this parameters. Then okay, there are some terminologies that we need to get familiar with them before we continue. So first is fractionation. There are some words that we need to familiar with them before we continue. Fractionation is not something complicated. It's just to separate chemical compounds. Okay, chemical compounds, a chemical mixture, a hydrocarbon mixture, a mixture of molecules that they have different molecular weight and different boiling point, to just separate them to various components. Okay, by distillation or sometimes by crystallization. Okay, crystallization is converting from liquid or from vapor to the solid phase. Okay, but here distillation is maybe from vapor to liquid or vice versa, liquid to vapor. Feed is a stream of hydrocarbon mixture that enters to the fractionator or the fractionation unit. Overhead, so in each of the equipment in the fractionation unit is a distillation column. You already studied distillation column in another course. So distillation column has a condenser at the top, okay, and it has a reboiler at the bottom, okay. So at the top, we extract our light product that we call it distillates. At the bottom, we get our bottom products that or heavier product, bottom products. So the products that we get at the top, we call it overhead products, OH products, that are the lighter hydrocarbons components, lighter hydrocarbon molecules. They have lower boiling point. And at the bottom, we extract our bottom products that are they are like heavier molecules, or they are the same mixture, the feed mixture, that the overhead product is removed from it. Then we have, okay, volatile component or volatile molecule, volatile component or volatile material is a product that will vaporize, significantly vaporize under normal temperature and pressure. Let's say if you have you have two small glasses, you fill one of them with water, the other one with alcohol, and you just leave them in your room. After a few hours or a few days, maybe all the alcohol will be disappear while the water will be still there. Okay, so in this case, alcohol is more volatile than water. Distillation is boiling and condensing of liquids. Okay, so you saw that in distillation column we have like in this slide we have a condenser at the top that condenses the vapor. We have a reboiler at the bottom that will, what does it do? It will vaporize. It will vaporize the liquid. Okay, it's boil or vaporize the liquid. So distillation is a boiling and condensing, boiling of liquid and condensing of vapor. This is better, is not good writing really. So boiling of liquid and condensing of vapor. And is a process that we separate the molecules with different molecular weights based on their boiling point, different boiling point, and we concentrate them, we purify them, and we separate them based on their molecular weight at the top or at the bottom of a column. So we purify the liquid by boiling it in the reboiler, because when you boil the liquid in the reboiler, whatever is more volatile, it will go to the vapor phase. So in this case, you can make your liquid pure in heavy molecules. And at the top that we have condenser, we condense the vapor, okay? And when you condense the vapor, whatever molecule is heavier, it goes to the liquid phase. So in this case, we will make your vapor purer in light molecules, because the heavy molecules, they will escape to the liquid phase. Vapor pressure is I'm sure you already saw this, or you have already seen this parameter in some other courses. In thermodynamic course, you will learn about this in more details. So vapor pressure is the pressure exerted by a vapor in equilibrium with solid and liquid. So when you have a two-phase mixture, when you have a vessel that you have liquid here or solid and you have some vapor at the top, the pressure that is exerted by this vapor, if you put, let's say, a pressure meter here, the pressure that is exerted by this vapor in the equilibrium condition is the vapor pressure. We call it vapor pressure. Reflux is this one here, this stream here. Is the stream, is the liquid stream that is coming from condenser. Okay, we condense the vapor here, we take our product as a vapor, and we get the liquid as a reflux back to the distillation column. So reflux refers to the portion of the overhead liquid products from a distillation column or fractionator that is returned to the upper part of the column. Okay, so reflux is the portion of the overhead liquid products from a distillation column or fractionator that is returned from the upper part of the column. This is what you already saw. Then, okay, this is the overall view of the fractionation unit. So like this is a very simple picture. So we have De-ethanizer, we have De-propanizer, we have De-butanizer, and De-isopentanizer. So you have your mixture, your feed coming here, the first column, the ethanizer, it will separate ethane from anything heavier than ethane. This separation, by the way, so your mixture has ethane and many other compounds that are bigger or heavier than ethane. So this first column will separate C2 from anything heavier. So this separation in this column or in the subsequent columns is not 100% perfectly separated. Okay, so here you have still some heavier molecules, but the majority of this stream is ethane. Let's say 90%, 95%, 98% is ethane. The rest, 2%, 1%, 3% is heavier molecules. Here you have majority molecules heavier than ethane, C2+. Let's say 98% is this type of molecules, only 1-2% maybe is ethane. So this distillation is not completely 100% complete. It's not a perfect ideal separation, but it does the majority job for us. Then C2 plus goes to De-propanizer. In De-propanizer, we separate propane from anything heavier than propane. Then we send molecule, the stream that is majority heavier than propane, we send it to Butanizer, Debutanizer, that we separate butane from anything heavier than butane. Okay. And in the last one, we have Isopentanizer, that we will separate isopentane from anything heavier than isopentane. Okay, so like we have mainly these four distillation columns. Here you have a bigger picture of this distillation of this unit. Okay, so that shows you all the, like all the accessory equipments that we have. So I'm gonna start from each of them. I'm not gonna go through the details of each of them, so because they are very similar. Each of them are a distillation column. Each of them, they have a reboiler. Okay, they have a reboiler. How the reboiler works? The reboiler works with a steam. Okay, so in the reboiler, we need a heat source. Heat source can be burning a fuel, burning a natural gas to create the heat, or we can use hot steam. Okay, we can use hot steam as a source of heat and heat the liquid and vaporize it. So each of this unit, they have a reboiler, so you can see it. And here you have, for some of them, you have the information about the operating condition of each of them, but it's not very critical to know. So we start from here, the feed to the first column, which is the De-ethanizer, okay? And the feed is coming at 55 bars and 55 bars and 73 degrees C. It goes to the De-ethanizer. We have Reboiler. We have a condenser, okay? We have a condenser here. And after the condenser, so what will happen? In the condenser, you get your ethane, and in the condenser you have, okay, after condenser you have two phase, okay. In the condenser you can also remove a little bit of heavier product like propane, and then you have a two phase, you send it to the reflux drum. In this reflux drum, liquid will be separated from vapor. Liquid goes back, it will be pumped. You have a pump here, it will be pumped back to the distillation column, and the lighter product, which is mainly ethane, is ethane here. It will be taken as your product. So, and you have also the condition, okay, the condition at the stream at the top for each of them. So this will continue. Then what you have at the bottom, you have heavier products, heavier than ethane, that it goes to the De-propanizer. Again, we have a reboiler, we have a condenser that is working with cooling water. So here we have a kettle type heat exchanger. Here we have another type. So we're not going to go to the details. So then we have two-phase separator that will separate our. We have a separator or accumulator that will separate liquid from vapor. What we will do, we will send some part of liquid to the reflux, and the other part of liquid we will take it as a propane. So you can see that here we will take ethane in the gas phase. Here we will take ethane, propane in the liquid phase. You see that all of them are coming from this part by these two pumps, and we take it as a liquid. Then heavier products, heavier than propane, it goes to Debutanizer. We have again reboiler, condenser, reflux drum that take the liquid. One portion of liquid will be refluxed back to the column. The another portion will be taken as our product, which is butane. And in the last stage, we have isopentanizer, that we have again reboiler, and at the top condenser. And we have also reflux here, okay, reflux stream here that send some portion of the liquid as a reflux. We take one side stream here, and also at the bottom, okay, we have really heavy products, heavier than isopentane, that will be sent to the storage column. Okay, it will be liquefied and it will be sent to it will be cooled down by using a cooling water here, and then it will be stored. So let's now go to each of this stage in more details, a little bit more details, to see what we have in each of them. I mean, like, what are the operating conditions, and some issues, some operational issues that we might face. Okay, so let me make it in this way now. I prefer to show you both of them in this way here. So I'll just bring it down a little bit here. Then I will make it this way. Okay. So now, I'm in this slide. So let me make this pen red here, and this one red. I prefer to work on both slides together. So fractionation unit, the description. So what we have, the liquid feed to the fractionation unit is the bottom product of a scrub column. So in the LNG plant, we have several units. Okay, this is a unit. Okay, I mean, like, you remember we had this picture in the previous unit, in unit 4. So we had several units to separate LPG, LNG, you know, like NGL. NGL is a bit different from LNG. LNG is liquefied natural gas, which is mainly methane. NGL is natural gas and liquids. It's a bit, maybe, you know, the names that we are using is a bit funny, but, you know, this is the standard that, you know, all the countries, all the companies, they accepted, and they work with each other in this way by using this kind of terminologies, and we have to also follow. We have no other choice. So we have our scrub column. Okay, what it does, like these two columns, both pre-cooling and scrub column, what it does, it do some separation for us. We have our natural gas that has a lot of components. Okay, so these components are mainly methane and some other heavy molecules like ethane, propane, butane, and so on. So we need to have a lean gas that is sent to the liquefaction unit, okay, or to main cryogenic heat exchanger. Okay, we need a lean gas. So lean gas means a gas which is mainly methane. Okay, so the reason is that if we send heavier products, since we have a very low temperature in the liquefaction unit, main cryogenic heat exchanger, so those heavy molecules, they can be frozen, and they can create some operational issues for us. So we have to try to remove them. Those heavy components like ethane, butane, propane, butane, they are called NGL, natural gas liquids. So we remove them, and then we send this lean gas, which is mainly methane. We will send it to main cryogenic exchanger. So we are talking about this part, that this stream from bottom of a scrub column. A scrub column is also a kind of is a refrigeration cycle that we use propane. So the bottom product here now, this will be sent to fractionation unit. Why? Because it has different components that we have to separate them. So now we are taking this stream and we send it to the first column, which is the De-ethanizer. We are here. So this is from bottom of a scrub column. It's from here. That is at pressure 55 bar and temperature 73 degrees C. We send it to a drum. We call it surge drum or surge vessel because it might be, you know, like it might be two-phase or it might be in liquid phase, or it might contain some vapor. So we will send it to the surge drum. In the surge drum, we can separate vapor from the liquid, and then we send it to the de-ethanizer column. So in the de-ethanizer column, I think I have the explanation in the next slide. Here. In the de-ethanizer, okay, the feed is received in the surge drum. This is your surge drum at pressure 55 bar and temperature 73 degrees C. Okay, so the de-ethanizer is a distillation column that has 52 trays. It's a tray distillation column with 52 trays. Okay, so then what we will do, we separate vapor from liquid in the surge drum, and we pick tray number 19. Tray number 19. We will send, so is like that. Tray number 1, 2, 3, 4, 5, 19. And then we have 20 here. So let me clean it a little bit here. Okay, we have 19. Then 20, 21, and so on. So this is your 19, this is your 20. So we send the vapor, okay? The vapor part, we send it just above the tray number 19, and we send the liquid just above the vapor tray number 20. Okay, so in the De-ethanizer, we separate them in the surge column. We send the vapor at the top of the tray number 19 and liquid at the top of tray number 20. Okay, and then they follow, the vapor goes up and liquid goes down. This is how the operation starts. Okay. So like we use this distillation column is a fractionation column, a distillation column with 72 trays. This is the De-ethanizer, right? 52 trays. We are using this tray to maximize, to allow to maximize the contact between liquid and vapor. Okay. In this case, we already talked about this in the PO 2410 when we talked about distillation column. We had a unit, a complete unit, which was also a long unit that was all about distillation column. It was showing the operation of distillation column, how the liquid and vapor are in contact with each other. So we have tray. On the tray, we have a weir here that we create a pool of liquid for us. So then we have liquid coming from top, vapor from bottom, and we have different type of caps here. Let's say we have bubble cap or kind of perforated plate that create those vapor bubbles for us, that they will be in contact with liquid and separation will happen. So once the liquid and vapor are in contact with each other, we have heat transfer. Not only heat transfer, we have also mass transfer. Mass transfer means that lighter molecules, lighter components, they will be evaporated and they go from liquid phase to the vapor phase. Okay, and we have also condensation of heavier product. Heavier product will be also condensed from vapor to the liquid phase. So this will happen continuously through the whole height of the column, and separation will happen continuously. And at the top we have a light product, and at the bottom we have a heavy product. Then we have So as a result of vaporization and condensation, the rise in vapor. So we have continuously vaporization and condensation. In result of this, the vapor that is going up, it will be pure in light product, and the liquid that is going down, it will be pure in heavy product. Okay, so at the top we have very light molecules, very light products, and at the bottom we have very heavy products or heavy molecules. Then we have fractionation, some other information. So since at the top of the column, since we go to the top of the column, we have vapor which is rich, pure in light product. So on the other hand, light products, light molecules, they have lower boiling point, right? Light products like alcohol has lower boiling point comparing with something like water. So since the boiling point will decrease, we have light product, that's why the temperature also decrease. So temperature, once we go up, will also decrease. So the temperature at the top of the column, let me just clean it a bit. Temperature at the top of the column is much lower than temperature at the bottom of the column, because here we have heavier molecules with higher molecular weight, and here we have lighter molecules with lower molecular weight. Okay, reflux, as I said, at the top we have a condenser. It's usually we can have partial condenser and total condenser. Partial condenser only partially liquefied the vapor. So you have your vapor receiving from here, it goes to the condenser. We only liquefied, the amount of liquid that we need for reflux. We take our product as vapor. Okay? We only liquefied, we only condense that much vapor that we need as a reflux. Why we do that? Because sometimes we need our product at the top to be in the gas phase. Why should I spend more cooling water, why should I have more heating cooling load here for a product that I don't want it in liquid? I just want it as vapor. So I just only condense as much as I need. So in that case, I can save a lot in cooling load. Okay, cooling load is an expense. We need cooling tower, cooling water. So that's the thing. So reflux, and by changing this reflux ratio, the amount of reflux, what I can. Okay, by the way, we can also take some of our product as liquid. Okay, we can create liquid. We can have both products we can have our product both in liquid and gas. And especially if it's a partial condenser, the vapor and liquid, they reach to equilibrium. It means the liquid products has different composition that gas phase. Okay, because they when they reach to equilibrium, their composition will be different. So then, since if we change this reflux, okay, we can changing reflux means different condenser load. Different condenser load means we create either more liquid or less liquid. So by doing so, we can also change the product that we send here to the product we send, the composition of the product that is sent back to the distillation column. So once the composition change, means we have different type of molecules, means we have different molecular weight, so we can or different boiling point. It means we can change the temperature. So the reflux can control the temperature at the top. Then okay, the temperature should be high enough at the top, okay, to permit complete vaporization of the overhead product. So we should have high enough temperature here, although the temperature at the top is lower at the bottom, but still we need to have temperature high enough to vaporize all the overhead products, the light products. Okay. If we have too low temperature, very low temperature here, if let's say we have a total condenser that condenses all the liquid vapor to the liquid, and even not a saturated liquid, subcooled liquid, we decrease the temperature too much, more than what we need. In this case, once you do that, you might have some of your light products that goes from gas phase to the liquid phase. Let's say you might send your ethane from gas vapor phase to the liquid phase, while you wanted to separate ethane here. So that means if you decrease the temperature too much, in that case, the yield of overhead products, the yield of ethane will decrease, because the ethane will go to the liquid phase. Okay, and too high temperature will lead to include higher boiling points. Okay, so too high temperature, if you increase the temperature too much here, so you might have some of the heavier molecules, heavier than ethane, let's say butane, propane, to go to the vapor phase, to the product phase, to the product ethylene. So then your product ethylene is not pure in ethane, it has some other molecule. So adjusting the temperature is a very critical parameter in controlling this column, or in general in controlling the quality of the product and the safe operation of this unit, this column. Okay, now we're gonna talk about some routine operation of each of this unit, and then like some issues that we might face. Okay, variation. So the feedstock, the feed that is coming to the De-ethanizer column here, it can sometimes change. For different reasons, it can change because it's coming from a scrubber, a scrub column. So if the condition in a scrub column change, the bottom product of the scrub column, which is the feed here, will change. So this the change in the variation will also affect how we operate this fractionation towers, fractionation unit. Depending to the composition that we are receiving, we have to adjust temperature, pressure, the reflux ratio in these distillation columns. Okay, so different composition. If you have different composition in the feed, we will get different top products and bottom products, and also in the different top products and bottom products. Not only difference in the composition, also the flow rate or the volume of the product will also change depending to the composition of this feed here, the composition of the feed that we have in this part. This is your feed. Okay, the change in the tower pressure and temperature. Okay, so if there is any change in the flow rate of this tower, the pressure and temperature of this tower, also this will change the top and bottom products, their compositions, their flow rates, and so on. Okay. In order to achieve on a specific products, a specification of the products, the operator will have to adjust. Okay, so once you receive your feed in the first column, let's say the De-ethanizer, so based on the composition of the product and the amount of the composition of the feed and the amount of the feed, the flow rate of the feed that you are receiving, the operator can play with the reflux ratio. Reflux is at the top of the column, okay, and also the steam, the amount of steam that is sending to the reboiler here. So he can play with these two parameters, the amount of reflux. How we can change the amount of reflux? With the cooling load. Okay, the cooling load that we have in the condenser, we can change the reflux ratio. And also at the bottom, we can change the amount of steam that we send to the reboiler to change the amount of vapor we are sending to the column. So by playing with these two parameters, the operator can adjust the composition, the product that we want at the bottom, at the top, and at the bottom. Okay, if we have an increase in the rate of the feed to the column, the first feed to the de-ethanizer, or we have a large amount of heavy molecules in the feed, so this also change the load of the fractionation tower. Load means we need more cooling load in the condenser and we need more heating load in the reboiler. So it means we need, when there is an increase in the load, it means we need more cooling water at the top and more steam in the reboiler. So it is highly recommended to avoid any change in the feed composition, because any change can really affect the whole process, whole unit. So we have to try to avoid any possible change. Then, okay, now the Euthanizer, we already talked about it, so now I'm gonna give you some more detailed information about that. The Euthanizer is used to separate ethane and lighter products from propane and heavier. We are trying to separate C2 from any products heavier than C2. As simple as that. So the objective is here to have mainly ethane and even lighter products, and we want to minimize the propane, because heavier than ethane will be propane, C3. We want to minimize the amount of propane and heavier product, heavier molecules here, and we want to maximize the amount of propane and heavier molecules at the bottom. Okay. This is our objective here. In the day-to-day operation, the following, okay, in the day-to-day operation, we might have this following issues. We might have high methane concentration in the top. Okay, not only ethane, we might have some lighter molecules like methane at the top, or we might have propane, high content of propane at the top. So high content of propane means instead of propane going here to the bottom is coming to the top. So here we can play with the reflux ratio, with reboiler load. We can change this. But for the methane, it's better that we separate methane before coming to this unit. Okay, it means better we separate it in the scrub column. Okay, or before that. So those are the issues that we might have. So if we have an excessive amount or excessive quality of methane in the overhead of the ethanizer, overhead of the top of the first column, the ethanizer column. So if you have methane has a high vapor pressure. The vapor pressure of the methane in the same temperature is much higher than ethane, butane, propane, and other products. So because it's lighter product, so it can increase the pressure at the top. So and it can cause flaring. Okay, it can cause or result in flaring the top products. Okay, because if we have a lot of ethane, we have no other choice than just flaring it. So how we can adjust it? So this stream to the feed to the de-ethanizer is coming from the bottom of a scrub column, right? So we have a scrub column. This is our scrub column. The bottom is going to the de-ethanizer. So this is also kind of unit that is a separator. So if we increase the temperature at the bottom, so let's say here we have a heater that we increase the temperature at the bottom. Once you increase the temperature and you vaporize this stream, the lighter product goes it will be separated. So if we increase the temperature here, if we add some heat or increase the temperature, we can separate methane from this stream. So we can send the feed that has lower amount of methane to the de-ethanizer. So this is the way that we can adjust the amount of methane, and we avoid methane to go to the de-ethanizer. And excessive propane in the overhead of the ethanizer. So if we have methane at the top, we can adjust it in a scrub column. If we have propane at the top, if here instead of ethane we have propane, we have C3, that might be due to two reasons. We might have too much heat from the reboiler. Here in the reboiler, I might add too much heat, that once I have too much heat, I can vaporize the propane and it goes to the vapor and it goes all the way top and it will be seen here. Or I have low flow of reflux. So here in the condenser, I don't have a lot of liquid reflux. I don't liquefy, I don't condense the vapor too much here. So since I don't condense a lot, I don't send the heavier molecules like propane to the liquid phase, and that's why the heavier molecules, they are still in the vapor, like propane will be still in the vapor. So it can be created by these two issues. In either case, what we do, we need to increase the reflux flow rate. Okay, if we decrease the reboiler heat duty or heat load, we can adjust it. But if we just increase the reflux flow rate, the reflux ratio here, we can adjust this issue. Then this is a kind of overall picture of De-ethanizer unit is this part here. Okay, is this part here that has been magnified. So you see, like, there are some other accessories units, like equipments, controller, that for now we don't need to know them. Just maybe in future, if you do any simulation, if we were using Semtronic, we could see all this controller, like this equipments in the unit. But for now, since we don't have access to that software, so we just mainly do some, like review the general components that we have in this unit. Okay, then after the Euthanizer, we have the De-propanizer. So we separate ethane here, we send the heavier molecules, that is molecules heavier than ethane, like propane, butane, we send it to the second column. So that the purpose of this column, the De-propanizer, is what? Is to separate propane and any lighter product at the top here, and butane and heavier product to the bottom. Here you have molecules heavier than propane, which is like butane at the bottom. So the objective is to have almost no butane here, no heavier products than propane here, and so minimize the amount of butane at the top, and minimize butane at the top and minimize propane at the bottom. We don't want any propane to be here at the bottom. We want the propane to be all at the top. In the day-to-day operation, the following operational, okay, again, is like the Euthanizer unit. If the operation is not done accurately, we might see some we might have, if the operation is not done correctly, or even the operation is not correctly done in the previous unit, we might have ethane here, a big amount of ethane, which is coming from this unit, or we might have butane here, butane that was supposed to be separated in the next column, it might be here. So in either case, is like previous unit, we can adjust it with the reflux ratio and also adjusting the heat duty in the reboiler. Okay, so for the ethane, for sure, it's better to separate it completely from the previous unit. But for the butane, we can, let's say, have more reflux. When we have more reflux, we send butane, which is heavier than propane, we send it to the liquid phase. Or here we can decrease the heat duty of reboiler, so we don't vaporize butane, we vaporize only propane. Then, okay. Excessive ethane, the ethane that is coming from other unit, okay, is like methane in the first unit, can increase the pressure in the De-propanizer, and it can increase the pressure at the top, and it has to be vented, or it has to be vented to the flare. It has to be burned in the flare. The ethane cannot be condensed in the De-propanizer, because the De-propanizer has the operating pressure and temperature to only separate propane from heavier molecules, heavier than propane. Okay, we cannot separate ethane. So if there is ethane at the top, we have to just send it to the flare. And if we see that we have butane at the top, okay, we can for the ethane, we can adjust if we have ethane here in this unit, in the second unit, we can adjust it by playing the operating condition in the previous unit, the Euthanizer. One way is that we can increase the temperature at the bottom of the Euthanizer. So at the bottom of the Euthanizer that we have Reboiler, here I can increase the temperature to make sure that all the ethane goes to the vapor phase, and there is no ethane that going to the next unit, to the second unit. Okay, so the problem of ethane can be adjusted by this reboiler. And if we have butane, excessive amount of butane here at the top, the butane, which is heavier than propane, supposed to be separated here, and it's supposed to be sent and separated in the next unit. But if we have butane here, we can adjust that by two methods. We can adjust it here. We can increase the temperature of reboiler, heat duty of reboiler, and we can, once you increase the heat duty, you will vaporize, you will vaporize all the light products like propane, and heavier products will be sent to the other stage, or by the flow rate of reflux. Okay, if we have if we adjust the flow rate of the reflux, we can also adjust the amount of the amount of butane here. Okay, is just, let me revise it. Okay, here is actually like okay. So in both cases, we have to maybe I said like for with high flow rate of reflux, but it's low flow rate of reflux. Okay, we should have lower flow rate of reflux to adjust any excess amount of propane here or butane here. Yeah. Okay. So, sorry. Like I just mixed up things here. So the amount of butane or propane at the top here is the reason is that we might have. Okay. Yeah. Sorry. Just I just correct my what I said. The butane that we have here, okay, at the top, which is a heavier molecule than propane, it might be due to two reasons: high temperature or high loading in the high loading of reboiler, okay, that we have more heat input to the reboiler or more temperature in the reboiler than what we need. So this high temperature in the reboiler causes that we send more volatile component to the vapor phase. So we send butane to the vapor phase here instead of in the liquid phase. If instead of keeping the butane, which is heavier than propane, the liquid phase, we will send it to the vapor phase, and that's why you will see butane here. So we can decrease the heating load of reboiler to adjust it, or it can be due to a low reflux ratio here. That in that case, we have to increase the reflux ratio. So to adjust this issue in both cases, we can increase the reflux ratio. And once you increase the reflux ratio, it means you have to condense more vapor. Once you condense the vapor, the heavier molecules, which is butane here, it goes to the liquid phase, and you will have purer propane at the top. So if I said the same thing for the same thing is exactly the same thing for the previous unit, for the de-ethanizer. So if you have propane here, it might be due to the high temperature, high heating load in the reboiler that you have to decrease it, okay, to keep the propane in the liquid phase, not in the vapor phase. Or you might have low reflux ratio here that you have to also increase it. Okay, increase the reflux ratio to keep all the heavier products than ethane back to the liquid. Then okay, slide 23. Okay, so here you see a bigger picture of the De-propanizer unit. As I said, with we don't need to go through the detail of it. Just show the different other different components like like the reboiler, like the different type of controller that we have to adjust the temperature of reboiler, condenser, the level of the liquid in the reboiler, in the condenser, and so on. That has and like many different valves that we have in this process. That, as I said, you don't need to go through the detail of this part. It's just for your information. Another unit is the debutanizer. Okay, debutanizer is so from the. Let me clean this part here. So from the De-propanizer, I have propane at the top and heavier molecules, heavier than propane at the bottom. Now I have propane, heavier propane molecules than propane. I send it to the debutanizer in this unit. Okay, debutanizer. In debutanizer, I will collect mainly butane at the top and heavier molecules, heavier than butane, like isopropane isopentane at the bottom. So I will remove butane at the top and heavier molecules than butane like isopentane at the bottom, and I will send it to the next column, which is the last column. So the objective of debutanizer is to minimize the heavy hydrocarbons in the overhead products here. We want only butane, heavier than butane. We want it to go to the bottom. So by reducing the heavy products from the light end in the de-propanizer is this unit. De-propanizer is this unit here. So we can reduce the chance of the heavy end freezing inside. Okay, so if we Okay, so in general, it's saying that if we try to remove as much as heavy products that we can, okay, from this stream, okay, especially from the propanizer, the ethanizer, and the butanizer, we can send lighter products. We will send lighter products to the main cryogenic heat exchanger. Okay, we send lighter product to the main cryogenic heat exchanger. So since we send lighter product, the chance of freezing inside that heat exchanger will be less. So when we can see there is a freezing problem in the main cryogenic heat exchanger when there is a high pressure drop in the cold bundle. Okay? The cold bundle that the temperature is very low, so those heavy molecules, they might freeze, they might be frozen or they might freeze, and that they can create a very huge pressure drop. An increase in the Butane reflux rate or a reduction of steam to the reboiler should rectify the situation. So if here I have a higher reflux ratio, okay, here I can separate, if I increase the reflux ratio, I can have a purer butane here, and anything heavier than butane can goes back to the column, or I can decrease the heat duty of reboiler. Okay, decrease the heat duty. That decreasing heat duty means we keep more heavier products here in the liquid phase than in the vapor phase. This is how we can fight with the issue that we have. Okay, the NGL. NGL is natural gas liquid. So let me go back here. What does it mean? NGL is here. NGL is here. This part here. And this is the NGL. Okay, that is coming from a scrub column, and we send it to the fractionation unit, the unit that we are currently talking about. So, sorry, let me go up here. Yeah. So The NGL product should have a minimum of light ends to prevent any gassing up in the floating roof hazard. So the NGL products, okay, that will be sent at the end, it will be sent for storage. It will be stored in the storage tank that are usually floating roof type of storage tank. You might have seen floating roof in your other courses like PO 1150. Yeah, PO 1150 that we talk about floating roof. So in floating roof, it's better that we have less volatile components. If you have more volatile components, they go to the gas phase and they will create the gassing of issues in the floating roof. So we have to try to have minimum amount of light ends product in the LNG, like light end molecules in the NGL esteemed, NGL natural gas liquids. So if you have a high vapor pressure in NGL products, that means we need to remove the light ends. There is an issue with light ends. Then, okay, so this is also a picture of the debutanizer system that, as I said, we don't need to go through the details, just shows like how different type of controllers, the valves, different type of, additional accessory equipment that we have, just for your information. Then, okay, the last unit is the last unit is the last unit is this unit here, De-isopentanizer. So in the De-butanizer, I separate butane from heavier molecules, heavier than butane. So then that the majority of this now is like molecules heavier than butane, like isopentane. So we send this ethylene to another column, another unit that we call it De-isopentanizer unit. So we send it to this unit and we will separate the De-butanizer here and from from other products, other molecules. We will separate De-butanizer at the top from heavier molecules. The heavier molecules, heavier components, they will be sent to the storage tank. As I said, those storage tanks. As I said, in those storage tanks, which is usually floating roof, we need to have a minimum amount of light ends, light molecules, to avoid the vapor accumulation or gassing off issues. So in the De-isopentanizer, what will happen? We produce plant contents. We produce the condensed that they have kind of low pressure drop, a low vapor pressure. Okay, we produce condensates. We produce products that are heavy, and they have a total vapor pressure which is equal to less than 1 bar at 45 degrees C is less than 1 bar, which is mix of hydrocarbons at very low vapor pressure. This is also a view of the isopentanizer unit. Is this unit here? So the isopentanizer is less complicated since it's the last unit. So since not connected to the next to another, like distillation column, that's why the operation is a bit simpler, because we collect the products and we just we collect the products from this unit, and we store them. Okay, we send them to a storage, and we use them for other applications. And okay, I have just one more slide about the control of such a unit, the fractionation unit. So the three main important parameter for operating parameter. for operating the fractionation unit is temperature, pressure, and flow rate. Temperature, pressure, flow rate, those are the three main operating parameters, okay? And all of them are also related to each other. If you change the operating pressure, the operating temperature will also change, because in the column, fractionation unit, we have distillation column, and distillation column is based on, the operation is based on equilibrium between vapor and liquid. In the equilibrium, if you change one parameter, the other will also change. So they are all interconnected to each other. So there is a specific protocol to how to change them. The operators, they know how to play with these parameters to not to disturb the operation, to not to change the quality of the products. And finally, is a summary of this unit. We learned about the fractionation unit, or we call it also fractionation distillation, to remove mixture of hydrocarbons heavier than methane from each other. So in this unit, you see that we separate ethane in De-ethanizer, we separate propane in De-propanizer. So those are used as a refrigerant. Those are the refrigerants that we use in the liquefaction unit. So they can be used as a makeup for the refrigeration purposes, refrigeration unit. So we remove heavier hydrocarbons, like hydrocarbons heavier than like propane, butane, like C4 plus. And we remove that because we cannot send this to the cryogenic heat exchanger. Okay, we have to remove them. Let's say if you are using C2 and C3 as a refrigerant, okay, in the refrigeration cycle in the liquefaction unit. So if these refrigerants, they have some heavier hydrocarbons with themselves, so these heavier hydrocarbons, they can freeze in the main cryogenic heat exchanger, and they can increase the pressure drop, which is the operational issues. And finally, if there is a variation in the feedstock, in the composition of the feed that is going to the fractionation unit, so that will also change everything, because depending to which type of molecules we have, the operating temperature, pressure, flow rate, all of the, for example, over the molar flow rate, for example, will change, and it will also disturb the process, and it will change the products that we get in the fractionation unit at the top and at the bottom. So that was all about this unit, and I hope you enjoy it. So please go through this unit, and if you have any question, you can always ask me, and I will be happy to answer. And thank you, and see you in the next unit.